Hey class, this is Gigi. I am going over written assignment number 16, question number 1, part B. The question here is asking you to find the radius of a convergence and interval convergence for the power series. So let's review again what these terminology mean. Okay, so here we have x minus a to the k power. That's the power series part, the power part of the series, right? So x minus 3, we have a center at 3 because a power series is of the form, c sub k, some coefficient multiplied by x minus a to the k power. And the a is where the center is, okay? And so looking at this here, we would say 3 is the center. When the question is asking for the radius of convergence, they are asking how far away from 3 can we go? And this series still is able to converge. So that's the radius of conversion. It's equals to what? We don't know, right? So that's what we're looking for. And then also, once we know the radius of conversion, we can write the interval of convergence. And when we write interval of convergence, we need to know whether to include the endpoints. So we do need to check at the endpoints. So interval of convergence, we need to check at the endpoints before we can write that. Okay? So here we go. In order to find radius and interval of convergence, we need to apply either the ratio test or the root test. For some reason, the root test is calling out for me. So I'm going to try the root test. So the root test said, take the limit as k goes to infinity of the kth root of the absolute value of that term right there. And the term is 2 to the k power times x minus 3 to the k power divided by k. All right, so looking at this here, k root k exponent, that's going to cancel each other, undo each other. I will have 2. And then x minus 3 to the k power, root undoes power, but we don't know what sort of root and what sort of value x minus 3 is, so we'll say it's going to equal to the absolute value of x minus 3. And then on the denominator, I have k root of k, which is k to the 1 over k power. And we are taking the limit as k goes to infinity. So when k goes to infinity, 1 over k is going to 0. Okay, so 1 over k is going to be approaching 0. And so k to the 0 power is going to be 1. So this whole thing here is going to be 1. So our limit is going to equal to 2 times absolute value of x minus 3. And the conditions for the root test is that whenever the limit is less than 1, then the series will converge. Okay, so we are looking at when is 2 times absolute value of x minus 3b less than 1. Well, that happened when absolute value of x minus 3 is less than 1/2. Okay, that means x minus 3 is going to be in between 1/2 and negative 1/2. So that x is really going to be in between at 3. So you will have 3.5. And on the other end, we'll have 2.5. Those are the endpoints of our interval. So let's go ahead and put those numbers on. This right here is 2.5. This right here is 3.5. And I'm not sure why I wrote decimal there when I said 2.5, but whatever, same. Okay, so the radius of convergence going from 3 to 3.5, the radius of convergence is 1/2. Now, as a matter of fact, 2 and 1/2, write it as a fraction so that we can do math with it a little bit better. Okay, so what are we supposed to do in order to answer the question of interval of convergence? We know radius of convergence is going to be 1/2. We know that, right? So in order to find the interval of convergence, we need to know what happened at the endpoints. Okay, so we do need to check for the endpoints. That means we have 2 series to check. Okay, so looking at x is 2.5. When x is 2.5, we plug that in for the x value right here in the series. So when we plug that in, the series that we have to look at now is when k is going from 2 to infinity of 2 to the k power x minus 3. Oopsie, I said plug in 2.5 for x, and 2.5 minus 3 is going to be negative 1/2 to the k power, all divided by k. Let's rewrite that for a second. Negative to the k power, that's going to give us, so this right here is negative 1 to the k power divided by 2 to the k power, right? And the 2 to the k power could actually cancel with that, cancel with the 2 to the k power. There. Okay, so that's 2 to the k power cancel with that 2 to the k power. And I'm not sure what happened, why that just disappeared, but that's what my computer is doing. So when I cancel it out, it just disappeared. So that's gone. Then what we really have is just this. It's the series that goes from k equal to 2 to infinity of negative 1 to the k power times 1 over k, or divided by k. This is an alternating harmonic series. An alternating harmonic series converges. So we know at the end there, at the end point, we know that we are going to include this endpoint. And we can go as far as, we're going to include this endpoint, and we can go as far as 3.5, and we know what happened at x equals 3.5. So when we do the same thing and we simplify, we'll get a very similar series, except for the 1/2 right there is going to be positive. So when we do simplify that, we get the series that go from 2 to infinity of 1 over k. And that is a harmonic series. And we know harmonic series diverges. So when we go back to our number line, we say that's an open interval right there. Okay, so our interval of convergence will go from So the radius of convergence is 1/2, and the interval of convergence is including 2.5, but not including 3.5. And that is our final answer for part B.